Hello, guys. You're welcome to today's exposition. Today we have a very interesting topic to discuss, and the title is testing the divisibility of numbers. Testing the divisibility of numbers. So this is it. I'm very sure that you've been once puzzled about if a factor will divide a given number without a remainder, or if there will be a remainder when a given number or a given factor divides another number. So if you have ever been in which I'm sure most of us have been, surely you're not alone. So today we are going to be looking at a couple of logics that will help us tell or that will help us know if a given factor that will divide another number without a remainder, or if there will be a remainder when a given factor divides another number. So before we go on, there are certain things that we must have. The first thing we need to have is the basic knowledge of division of numbers. So if you don't have the basic knowledge of division of numbers, you may find it quite difficult to understand what we're about to take. So we beg you to just probably take a break and go understand the basic division of numbers. So the next thing you need is 100% concentration. So here's the logic. How do we get to know if 2 will divide a number without a remainder? How do we tell? So this is what we have to do. Check if the last digit of any number is even. What are even numbers? These are the set of basic even numbers: 0, 2, 4, 6, 8. Or odd: 1, 3, 5, 7, and 9. If even, 2 will divide perfectly such a number, but if odd, there will be a remainder after division. So it's very easy for me to know if 2 will divide a number without a remainder, or if 2 will divide a number with a remainder. And here's the logic as stated here: if the last digit of any given number is even, that is what 2 can divide, a multiple of 2, it means 2 will divide such a number without a remainder. But if the last digit is odd, it means when 2 divides such a number, there will surely be a remainder. So here is an example. Prove 57,530 divided by 2. Or test 57,530 divided by 2. When 2 divides this number, would there be a remainder? It's a simple thing. We have to bring out the last digits first. That's the first thing we have to do. 0 divided by 2, as you can see, 0 is an even number. 2 in 0 is 0. There is no remainder. So now let's divide. As I said, you need a basic knowledge of division. Let's see if this test is correct. So how do we know if the test is correct? The only way we can get to know is by dividing now to see if surely after this division, there won't be a remainder. So we are going to use what we call the one-on-one division. 2 in 5 is 2. 4, remainder 1. 2 in 17 is 8, 16, remainder 1. 2 in 15 is 7, 14, remainder 1. 2 in 13 is 6, 12, remainder 1. 2 in 10 is 5. So it's very simple. As you can see, you can easily get to tell or know if there will be a remainder or not when 2 divides a number just by checking the last digit. So there's another example we have to look at here. Prove 7513055 divided by 2. When 2 divides this number, how do we tell if there will be a remainder or not? It's very easy. Bring out the last digit, check if the last digit is even or odd. So when we look at the last digit, 5 divided by 2. 2 in 5, what do we have? 2 in 5 is 2 remainder 1. 2 in 5 is 2 remainder 1. It means there will be a remainder when 2 divides this number. So let's quickly see if our proof or if our test is correct. So 2 in 7 is 3, 6, remainder 1. 2 in 15 is 7, 14, remainder 1. 2 in 11 is 5, 10, remainder 1. 2 in 13 is 6, 12, remainder 1. 2 in 10 is 5. 2 in 5 is 2, 4, remainder 1. 2 in 15 is 7. 14, remainder 1. As you can see, 3, 7, 5, 6, 5, 2, 7, remainder 1 over 2. So it's very easy for you to know if 2 divides a number perfectly or not, even before you divide. So you don't need to be puzzled or phased any further. And one thing is, regardless of how big the number is, all what you just have to do is to check the last digit. If 2 divides the last digit without a remainder, it means there won't be a remainder. But if there's a remainder, that is, if the last digit is an odd digit, it means there will surely be a remainder. So yeah, I have a couple of questions for you to try out. So you leave your answers below in the comment section. So prove this for me. Prove or test. Prove or test. So all what I just want from you is to tell me if there will be a remainder or not. Just write remainder or no remainder. So see you in the next exposition.